Target 6.4, I can predict the products of a reaction if given the reactants. Before you predict the products of a reaction, you have to be able to classify the reaction. We'll look at synthesis reactions first. Synthesis is of the type where two elements or two compounds combine to make one single product. You will only be required to predict the products of simple single replacement or simple synthesis reactions where you have two elements combining. So that's all you have to do. Predicting products of synthesis reactions, you just make a compound from the elements A and B. So, and also you need to remember to cross over your charges. For example, you look at magnesium plus oxygen, and the only thing possible is for them to combine if a reaction is going to occur. So you have to combine magnesium and oxygen. So you remember to write the symbols and their charges. Those two cancel out, therefore the formula is MgO. Once you've written that, then you go back and balance it. So to balance this, I would need a 2 here to make 2 oxygens on this side, and then I would have to come over here and put a 2 there to make 2 magnesiums, and that's done. The second one, aluminum plus oxygen, again, you're going to combine your aluminum and oxygen, so you have to write the element symbols and their charges and cross them over. So that would be Al2O3. Now that you've written it, go back and balance it. 3 oxygens there and 2 there. No way you can make 3 here, and there's no way you can make 2 there, so make both 6. If I'm to have 6 oxygens on this side, then I will have to multiply this whole thing by 2, which gives me 6 oxygens. Here I will have to multiply this by 3, which gives me 6 oxygens. When I put the 2 here, that gave me 4 aluminum, so I'll have to come over here and put a 4 there, and now it's balanced. And that's synthesis. The next type we'll look at is decomposition. This is simple as well. You have a compound, you break it into its elements. You will only be required in this course to break a compound into 2 elements. You won't have to do anything more complicated than that. So H2O, break it into its elements, which is hydrogen and oxygen, but remember that hydrogen is diatomic and oxygen is diatomic as well. And then in this case you would just go balance it. And since I have 1 oxygen here and 2 there, I'll put a 2 there, then I have to put a 2 there, and it's balanced. One more example. MgO, break it into its parts. Magnesium is not diatomic, so I do not need a subscript here. Oxygen is diatomic. So then you would balance it. Since there are 2 oxygens here, put a 2 there. You'd have to put a 2 there, and now it's balanced. That's decomposition. Single replacement. When a single element is a metal, it replaces the metal in the compound. So in this case, if A is a metal, it will replace B. Because remember, your metal is always written first in the compound. Also, when you're predicting the products of a single replacement reaction, remember to always check the activity series first to see if it will happen. Just because I can write a reaction doesn't mean that anything will happen if I actually put element A into compound BX. So, magnesium is a metal, therefore I have to check to see if it will replace copper, and magnesium on my activity list is higher than copper, therefore yes, this reaction will happen. So magnesium will bump copper out, and you will have a compound between magnesium and nitrate. Remember to write your element symbols and their charges, and then cross them over. And so the formula is magnesium nitrate plus copper. Then you would go back and balance it. In this case, it's already balanced. Now, when the single element is a nonmetal, as in this case, you look to see if it will replace the nonmetal. It will replace the second element if it is more active. So you compare bromine and iodine, and if you look on your list, bromine is higher than iodine, so yes, this reaction will occur. So bromine will take iodine's place and combine with potassium. So you're going to put K and Br together. K is +1, Br is negative, so it's just K, Br. And then I goes by itself, but I is a diatomic element, so you need a 2 there. Then to balance it, you would just do this, and that's done. Double replacement is pretty easy. You're just going to put the metal in this compound with the nonmetal, and the metal in this compound with the nonmetal in that compound. So combine A and X and B and Y, cross over your charges, then balance the equation. So metals trade partners. For example, FeS plus HCl. You're going to put Fe with Cl and S with H. Since Fe here is plus 2, that's iron 2, I'm going to keep it that way. So it's Fe plus 2 and Cl minus 1. So your compound will be FeCl2. And then hydrogen with sulfur. Hydrogen is plus 1, sulfur is negative 2, H2S. Then you would balance it by putting a 2 here. Just trade partners. And this one would be Na and sulfate, so Na2SO4 plus H and Cl. They're both 1, so it's HCl. Then I would need to balance that by putting a 2 there and a 2 there, and it's balanced. That's double replacement. Combustion is very easy because you just have to memorize that anytime a hydrocarbon burns, the products are always the same. It's always carbon dioxide and water, no matter what the hydrocarbon. CO2 plus H2O. Then you go back and balance it. And we will end there.